Now I am going to solve some simple problems, like if somebody gives you Young's modulus E1, E2, G12, mu12 or mu21. Even before that, I may ask that E2 by E1 and mu12 is equal to mu21. So, using those relations we can find out mu21. If E2 is known, E1 is known, mu12 is known, then you can find out mu21. Why it is required? You see that elastic coefficient using these materials. When we are going to develop a plate theory, we have to find out Q11, Q12 numerically. So, E11, 1 minus mu12, mu21. For isotropic, Q11 will be E by 1 minus mu square. Okay. So, in the assignments, we may ask that how to evaluate a Q11 for a given material property. Similarly, how to evaluate a Q12, mu12, E2. These are the very standard relations, or I would like to say the basics of structural mechanics. If we are not comfortable with this, we cannot proceed further. We must know that how to evaluate Q11, Q12, Q22 and Q66 is nothing but G12. If you remember exactly, there I have said an XX. What is that? A11 of epsilon XX of naught plus A12 of epsilon YY of naught. That is the plate constitutive relations. So, for that we know how to evaluate A11, A12. So, A11 is, by definition is Qij and dz minus h by 2 to plus h by 2, where Qj is a constant. So, basically Qij into h times will be Aij. Here Ij goes from 1 to 2. So, A11 will be nothing but E by 1 minus 1 to 2 1 into thickness of that plate. So, we can evaluate A11. If we know A11, if we know A12 and through some experiments we are able to at any point the strain epsilon xx naught, epsilon yy naught, we can evaluate nxx. A12 is mu21 into A1, A22, E2 by E1, A11, then A66 up to here. This is your extensional stiffness. These formulas are important. We must remember these things so that we can evaluate or we can calculate during the assignments or exams or some point of time. Now, we are talking about the bending stiffness. If you want to evaluate moment mxx, what is that? It is minus d11 of w comma xx minus d12 of w comma yy. So, this is your moment. So, you can evaluate d11 is E1 h cube 12 minus, or in another terms I can say that q into h cube by 12. In other sense, d11 is this thing. If somehow you know that q11, you can calculate the d11 h cube by 12, or you know the d11, you can calculate the q11. Similarly, d12 one can calculate. So, unit should be small k, there is some mistake, kilonewton. Then d22, q66. Now, the question that material x is are orientated at 60 degree and x3 equal to z. Then you have to evaluate bar transformed one, which will be a cos 4 and so on. Then based on this effective transformed reduced stiffness, A11, A12 can be evaluated. Okay. I have already told you that if your E1, E2, E3 all things are given, and then at any some point of time epsilon xx naught is given. So, it is, we are going to read the statement that a orthotropic plate is subjected to only non-zero strain is this, then we have to interested to find out the state of stress at that point, and thickness of the plate is given, material properties are given. So, you can evaluate sigma xx is q11 of epsilon naught. So, for this purpose we know how to evaluate q11. q11 is what? q11 is E1 by 1 minus mu12 mu21, and what is that q12, and similarly q16 later on. So, they have evaluation, and if you substitute it there, you can evaluate the sigma xx, sigma y, sigma xy. Then stress resultant nxx, nyy, nxy, only epsilon xx naught is non-zero. So, only contribution will be A11. So, if you multiply with that, you can get what will be the moment. For the case of moment, it should be epsilon xx of 1. So, there is no epsilon xx of 1. So, moments will be 0. So, these type of questions or the numericals, when you are going to make a program for a plate, so you must know these formulas, that how to evaluate this, you are going to use those. At the end of the day, you need some number, that deflection should be in some numbers, moment should be in some numbers. So, you have to evaluate these things. Now, I am talking about that now you have known that how to evaluate q11, how to evaluate a11, how to evaluate d11 and corresponding sum 1, 2 and so on, and how to evaluate nxx and mxx for a given point or a sigma xx and so on for a given numerical data. The next is to evaluate or obtain, if you remember, with QMN. That QMN definition was, that is also required for the solution. If you want to solve a plate problem, you have to at least up to here all material constants and QMN. So, QMN definition wise was 4AB 0 to A, 0 to B and QXY sin m pi x by A sin n pi y by B. Now, I am saying, let us say my QXY is nothing but just a UDL kind of thing, Q naught, not a function of anything. Then what will be my QMN? So, you have to solve this integration. What will be that? Just put it there. This is very, very much important. Most of the time, we understood the theory that how to represent or how to develop a governing equation for a plate. But for making a program, for getting the solutions, we must know these basic things, that how to evaluate. Program will not give you the final solution. You have to write your own code or your own program, that this will be equal to something and that we are going to use that. Let us say Q naught sin m pi x by A sin n pi y by B dx dy 0 to A 0 to B. So, this is solely a function of x, this is solely a function of y. So, we can integrate. So, basically Q naught for AB you put it here and then Sine will be minus of cos m pi x by a upon m pi by a. Units 0 to a. Then minus cos n pi y by b and n pi by b, 0 to b. So, this you further simplify, a and b will get out cancel. So, basically 4 q naught m n, again pi square will come up here and here, minus cos m pi x by a 0 to a and minus cos m pi n pi y by b 0 to b. Then what is that? Put a, so becomes get cancel out, cos minus m pi. Okay, and then lower limit minus upper limit, or you first put it 0. Cos m pi only, and then this cos 0. So, when you put 1 m pi, so basically I am going to put it here 1, this is minus, yes. So, cos 0 is 1 minus of cos m pi, then if you put pi, m is equal to 1, cos pi will be minus 1, then it will become 2. When you put m is 2, then it will be cos 2 pi, which is plus 1, then it becomes 0. So, this series is valid only m is equal to 1, 3 and 5 and so on. Similarly, here cos and pi 0 to b, minus of that. So, basically 1 minus cos and pi, you can put like that. So, if you put 1, it becomes 2. So, ultimately 2 from this, 2 from this. So, 16 q naught m n pi square, and that is valid for m is equal to 1, 3 and n is equal to 1, 3 and so on. So, we can evaluate this function like this. Now, come to the second most important function. If your qxy is represented sin pi x by a and sin pi sine loading, then your QMN will be 4AB 0 to A 0 to B, put it this thing and you say Q naught something value sin pi x by A sin pi by B and then sin m pi x by A sin n pi y by b dx dy. So, here you see that sin x and sin c. So, basically if you remember sin A and sin B formula, which is basically A plus B, A minus B minus of cos of A plus B, like this some formula. So, if you put it there, so I would like to say, let us say m pi is greater, so I would like to like that into this minus m pi plus pi of x and so on. So, you can say that cos of pi minus 1 is into x. So, this first term, when you put m is equal to 1, it becomes 0. When you put m is equal to 2, okay, then series goes like that. So, we can say this term can be written as 1 plus of cos m minus 1 pi x. So, basically you will say that m bar, where m bar is nothing but m pi by a again, okay, pi by a, and or here also na pi by a, some there pi by b, these things will come up. So, here this goes from m is equal to 2. Similarly for this case. So, if you do that integration of a cos function, it will be sine. So, you take any value, sine pi, sine 2 pi, sine 3 pi, sine 4 pi, contribution will be 0. So, I would like to say the gist of is this, that for such a case it is just becoming q naught plus cos of something plus cos of and something and so on. So, they will give you integration. So, 0 contribution, only q naught come up till there, non-zero contribution 1. So, qmn a, b, they will cancel out and 2 in this, and you can take 2 again. So, qmn is just q naught. So, that is the easiest one. When I say that a plate is subjected to a sinusoidal loading, then you understood that qmn must be just q naught. For most of the time, for simplification or just to expose you that what will be the stresses or moments, we used to assume that our loading is bisinusoidal along x and y as is. So, qmn will be q naught, and we can solve that deflection, moment and stresses, so on. We may give qxy is like that, q naught x by a linear function, or sometimes q naught xy ab, any kind. So, then you are supposed to evaluate that qmn. Even evaluating this qmn is a important, or I would like to say that sometimes that making a function is a challenging task. That if you see in a book that how to represent, if this is the only a triangular loading increasing, that to say that along x axis, sometimes we call it as a hydrostatic loading, okay, q naught x by a, this is there. But if you have a loading like this, a pyramid shape, then how to make this function? So, it will be a two regime, one is this, then combining together. So, one function will be valid up to here, another function will be valid up to here. But if you have a sine series 1, or if you have a function like this, then you can assume in terms of a sine series or some polynomial functions for this case. So, our aim is to find out first how the loading is there, and based on that qmn. So, evaluating of a qmn is a very important task if we are interested to get the deflection moment of a plate.